Geometry, Chapter 1, Section 5. Here's our vocabulary words for the section. So take a moment, put pause, and go ahead and copy all these words down, and then I'll come back and discuss them for you. Okay, welcome back. Adjacent angles. Adjacent means next to, so we want angles that are next to each other. So we've got angles ABC here and angle ABD. They would be considered next to each other because they touch each other. They share AB as a side. B is the vertex of both. So those would be adjacent angles. Angles that are not adjacent. Let's see, let's go look at this example here. Angles that are not adjacent. Angle ABC, ABC, and angle ABD, ABD. So let's make those darker so we can see them. Let me grab that and change this to like green. So we've got A, B, C. That's one of the angles. And then let me change my line color again and go to red. And this is going to be A, B, D. So the green one and the red one share a common side. They share a vertex, but point C is in the middle of it, so they aren't adjacent. One is actually inside the other one, so these are not considered adjacent. And this next one, let's look at this one. We've got ABC, so A to B and B to C. That's one angle. And then our other angle, let's go with the green again. So it's ABD. Nope, need to go with this one. This one is probably, let's make this go away. BCD, B to C to D. You can see they have a common side, but they don't share a vertex, and they are going in opposite directions. So these would not be adjacent angles either. So adjacent angles, they share a common side. So A to B to C, and then C to B to D. Okay, they both have this BC as a common side. They share B as a vertex. Those are definitely adjacent. Okay, let's go back to our list of vocabulary words and get the next word. Okay, vertical angles. Vertical angles are not adjacent. They are not next to each other. Adjacent next to each other, right? So vertical angles are not next to each other, and they are formed by two intersecting lines. So here we have two lines, lines AE and lines CD, and they intersect here at point B. And you have two vertical angles. You have a vertical angle up here, and you have a vertical angle down here. Those are considered vertical. And you also have a vertical angle here and a vertical angle over there. So these two are considered vertical. Vertical angles are always two angles. They go across the vertex, and they are formed by two intersecting lines. Notice that whenever I take my intersecting lines and I rotate them, right, these two angles are the same still, and these two angles are the same. I put that back and go the other way, same thing. These two angles would be the same measure, these two angles are the same measure. That's why we study vertical angles, because they have the same measure. Linear pair. Again, we're back to adjacent, which means next to. So two angles that are next to each other, and they have non-common side or opposite rays. Opposite rays means they form a straight line. So if you take angle DBA, this angle here, DBA, and let me clear off some of our markings here. So I'm going to take angle DBA, that's this one, DBA, and I'm going to look at angle ABC, it's this one here. Okay. Those two angles are a linear pair. They form this line CD. There's no extra space, they don't missing a space. They form a line with DC. They have a common side. This BA ray is their common side. So that's a linear pair. Complementary angles. Complementary angles form 90 degrees. Supplementary angles form 180 degrees when you add the two angles together. And perpendicular means right angles. Let me go down and give you a little bit further explanation here. So again, vertical angles, AED would be vertical to BEC here, right? This one here and this one over here. Those would be vertical. Also, AEB and DEC would be vertical, these two. Okay, so they are congruent to each other, they are vertical. Over here we don't have any vertical angles because we do not have intersecting lines. There is nothing that intersects, no vertical angles. Linear pair, the last thing down here, this angle DEB and angle BEC, these would be a linear pair because they form line DC. No linear pairs here because we don't have two angles that form a straight line. Let's see, I also have vertical angles some more. So the angle on this side would be congruent to the angle on this one. So LPH is congruent, or the same measure of JPK. They are vertical angles. JPL, this top one up here, is going to be the same measure as KPH, this bottom one, vertical angles across two lines that intersect. Complementary angles, again, two angles, angle 1 and angle 2 here add to be 90 degrees. Angle 50 and angle 40 over here, they add to be 90 degrees. They don't have to touch. They can, but complementary just means they add up. The 50 plus 40 equals 90. They are complementary. Same thing with supplementary. These two angles form a straight line. They are a linear pair, so they have to be supplementary. They form 180 degrees. These two are also supplementary. They don't touch. They don't have to touch. So 100 plus 80 is 180, so they are supplementary. And the last thing was perpendicular lines. So perpendicular lines intersect to form four right angles. If you know that WY and XZ are perpendicular, then you know that if I call this point T here, YTZ has to be 90, YTX has to be 90, XTW has to be 90, and WTZ has to be 90. Let's see, perpendicular lines intersect to form congruent adjacent angles. Congruent means the same measure. Okay, so you know that all four of these angles are congruent because they are all the same measure. They are all 90 degrees. Segments and rays can be perpendicular to lines or other lines and rays. So you can deal with rays, you can deal with segments, you can deal with lines. It doesn't matter. Perpendicular is perpendicular. And the right angle symbol in the figure indicates that the lines are perpendicular. This box right here, that box in the corner means 90 degrees or perpendicular. So perpendicular is this symbol right here also. It's like an upside down T. The upside down T is also perpendicular to. So all those are ways of saying perpendicular to.